Hello, everyone. You made it to the last unit of geometry, which is probability, unit 7. So we're going to start with some basic vocabulary today, and that is called sample space. So the sample space of an experiment, sample space, is the set of all possible outcomes. Okay, so kind of like when you say, what are the chances of this happening? That is what probability is mainly geared towards. So a sample space can be represented by using an organized list, a table, or a tree diagram. Okay, and this would all make sense once we do an example. All right, so here's an example. Represent the sample space by making an organized list, table, and tree diagram. So remember, the sample space is what are the outcomes that can happen. So right here it says the baseball team can wear blue or red shirts with black or white pants. Okay, so those are our options. And so to do the sample space, we have to think of all the possible outcomes of the uniform outcomes that they can have. Starting with a table, what are the two things that consist of this uniform? Well, we have shirts. I'm going to put that up here. Shirts. And then we have pants. So just turn your paper sideways. We have shirts and we have pants. Okay, and then what color shirts can they wear? They can wear blue or red. Blue or red. Okay, and then for pants, they can either wear black or white. So black. I'm just going to use orange, black or white. Okay, those are our options. And so now we're going to list out the outfits that can be put together. So you can either have black pants, I'm going this way, black pants with a blue or red shirt. Okay, do y'all see that? Going this way. If you wear black pants, you can either wear black pants with a blue shirt or black pants with a red shirt. All right, and then the other option with white pants is white pants with a blue shirt or white pants with the red shirt. Okay, and that's it. That's the possible outcomes. So your outcomes are represented in this part of the table. Okay. All right, let's do a tree diagram. So we're talking about outfits. Okay. And what the players can wear. So a tree diagram has like these branches. That's why they call it a tree diagram. So they can either wear black pants or white pants. And then once they pick their pants, they can either wear blue shirts or red shirts. Okay, but you have to branch off each one. So if they go this route, they pick black pants, they can either wear blue shirt or red shirt. If they pick white pants, they can wear blue shirt or red shirt. And that's all that we have. Okay, so there's a tree diagram. And then an organized list, you just list out your options. So kind of like what we have here in the table. So do a little bracket. So they can wear black pants with blue shirt. They can wear black pants with a red shirt. white pants with a blue shirt or white pants with a red shirt. All right, and those are our outcomes. So all three of these are examples of a sample space for probability, okay? Let's go on to the next one. This is the fundamental counting principle. So this is the number of all possible outcomes for an experiment, and this can be found by multiplying the number of possible outcomes from each category or group. And then we'll see what that means. Okay. So let's say you go to buy some burgers. How many different burgers can be made from the options listed below? So how are you going to find this? Well, it tells you right here. All you have to do is what? Multiply the possible outcomes for each category or group. So how many outcomes of burger size can we pick from? Well, it says we can do a slider, a regular, or a large. So that's 3 outcomes for burger size. Okay. What cheese options do we have? We either have cheese or no cheese. So that's 2 options. What about tomato? You can either do tomato or no tomato. So 2 options. And then for the sauce, you can pick ketchup, mayo, or mustard. So that's 3 options. In order for us to figure out the different types of burgers we can make, we multiply all of those numbers. So you're literally going to multiply 3 times 2 times 2 times 3. Okay? So list it out and you're going to multiply. And when you do that, you get 3 times 2, which is 6. 6 times 2 is 12. 12 times 3, 36 possibilities. Okay. All right, that's the counting principle. And now let's do some basic probability. All right, so like I said, basic probability is determining how many desired outcomes can happen in relation to the total number of outcomes. Okay, so the way we're going to express these probabilities is going to be ratios, which is this another word for fractions, in reduced form. Okay, so we have to simplify. All right, so what does that mean? Here's an example. What is the probability of rolling an even number on a die? So if we think of a die, there's 6 numbers, right? Let's list them out. How many sides does a die have if it's a cube? How many faces? 1. It has 4, and then the top base and the bottom. So 6. So we have numbers 1, 2, 3, 4, 5, 6. These are the numbers we can get on a regular die. Okay. How many of those numbers are even? Well, 2 is even, 4 is even, 6 is even. The other ones are odd. So out of the total 6, how many of them are even? 3. 3 out of 6. But we have to simplify. So how can we simplify this fraction? Both of these numbers are divisible by what number? What can you divide both of those by? By 2. No, not 2, sorry. By 3. Okay. I'm currently still pregnant when you're watching this video, so please don't mind my pregnant brain. So what does that simplify to? 3 divided by 3 is 1. 6 divided by 3 is 2, so 1/2. That is the probability that you are going to roll what kind of number? An even number, okay? All right. Let's look at this one. The probability that a 7th grader chosen at random will play the guitar. But this time they want me to express my answer as a percent to the nearest whole number. Okay. All right. So here's a table they gave us. What is the probability that if we pick one of these students, they play the guitar? So I have 4 different instruments. Here's my guitar category. And only 2 of them play the guitar. Out of how many? What's the total? They didn't give us a total, so we just have to add. 2 plus 6 plus 3 plus 5. That's going to be total of 16. Yeah. 6, 7, 8, 9, 10, 11. 11 plus 5, 16. Yeah. So 2 out of 16. But they want me to give my answer as a percent. So let's go to Desmos. Okay. All right. 2 out of 16. What percent is that? So as a decimal, it's 0.125. Okay. So write that down. That's the decimal. To convert it to a percent, we move the decimal 2 spaces to the right. Okay, you see that? 1, 2. So 12.5. But they want the answer as a whole number. So what does that round to? 12.5. It rounds to 13. So 13% is our final answer. Okay. All right. That is it for intro to probability. You do have a Delta Math to complete, so go ahead and log in and do that Delta Math. Thank you.